Hello and welcome to this Data Platform Summit session on SAP connectivity in Azure Data Factory and Azure Synapse Analytics. My name is Ulrich. I'm a program manager in the Azure Data Factory team at Microsoft, mainly focusing on SAP connectivity. And I'm really happy to share with you some of the exciting innovations which we have shipped with the last updates in Azure Data Factory and Azure Synapse Analytics in regards to SAP connectivity in the last couple of weeks or months. So without further ado, let's have a look at the agenda and then jump right into the topic. So what are we going to cover in this session? We'll start off with an overview of the existing SAP connectivity in ADF, which has been in GA for quite some time. So we'll basically review what has been there for a while already. And then we'll mainly put a focus on the exciting innovations which we have been shipping over the last couple of months, which mainly deal with change data capture or delta capabilities for SAP sources in ADF and Synapse. And we'll do this both in theory, based on slides, which explain the concepts of this development and the frameworks and technologies behind it. And of course, we'll also spend a lot of time on a system demo so that you get a real life impression of how this really works. So let's recap the existing SAP connectivity. On this slide, you see the 6 dedicated SAP connectors which have been around for quite some time. We have dedicated connectors for certain SAP products like SAP ECC, which is a connector that mainly focuses on OData services exposed by SAP ECC. For SAP BW, we have 2 connectors, one for the Open Hub interface of BW and one for BW queries via MDX. So that's a second option here. We have a dedicated connector for SAP Cloud for Customer. There's a connector for SAP HANA, which is basically based on generic ODBC connectivity. And we have one very general connector, the so-called SAP Table Connector, which basically allows you to connect to tables in your SAP system via the application server on pretty much any NetWeaver-based SAP system. So this table connector can be used for SAP ECC systems, for SAP S/4HANA systems, and can also be used for BW in principle. So there are many systems which this specific connector can cover. So overall, you see that the connectivity we cover is basically addressing a wide range of the most widely adopted SAP solutions. So that's really great. You can also see that the connectivity which we have provided in the past is mainly based on open standards. So I mentioned that the ECC connector is leveraging OData services exposed by ECC. The SAP HANA connector is using ODBC or JDBC connectivity. So that's also a standard and an open standard on which this is based. The table connector internally basically translates an RFC call into the SAP system into a SQL statement. So that's basically also a SQL and RFC based connectivity. So it's very much based on open standards. An important thing to mention here, all these connectors come out of the box with ADF to you, or same applies to Azure Synapse Analytics. So there's no additional cost or licensing associated with them. You can use them for free, and they are available to anyone. From an adoption perspective, we see the highest adoption on those connectors for the SAP HANA connector, the SAP Table connector, and the BW Open Hub connector, which is probably not surprising. If you look at especially if you look at the ECC connector, OData services have been around for quite some time in SAP ECC, and they play an important role. But for mass data extraction, of course, other technologies like SQL and RFC or JDBC, for like in the case of the HANA connector, or also the connectivity to BW via Open Hub is typically preferred by most of the customers. So from that perspective, it's quite clear that for ETL aspects and mass data extraction, the focus lies on those 3 connectors which I have mentioned. Now, there's another aspect which is sometimes ignored in that context, but I think it's very important to mention. Besides the dedicated connectivity which we have provided for SAP, you can of course also use other connectivity options which can be used in combination with SAP. So for example, HTTP or OData communication via Azure Functions or Azure Logic apps all that can be used in ADF and orchestrated via pipelines, for example, for certain purposes where the dedicated SAP connectors maybe reach their limits. So, for example, when it comes to bidirectional communication, writing back into an SAP system, such functionality is not provided by our connectors, of course, because they're dealing with data extraction. But you can still use functionality which can be orchestrated by ADF and is available out of the box to you in that context as well. And last but not least, we should also mention that just like with the SAP HANA connector, if your SAP system is running on another database like SQL Server, IBM databases, or Oracle databases, there's always the technical option to extract data on database layer. This is, of course, a tricky topic in some regards. It has some aspects which you need to take into consideration from a license perspective. It's also slightly different from a technical perspective when you look at data types and formats than when you reach out to the SAP system via the application layer. But still, it's an option you should have in mind and you can consider if needed. So let's move on to the most recent innovations we have shipped in terms of SAP connectivity. And those innovations mainly deal with change data capture or Delta capabilities for SAP. The core of these innovations which we have recently shipped is the so-called SAP ODP connector. Before I go into the details of ODP, for those of you who have not heard the term yet, people familiar with SAP and SAP analytics and data warehousing tools might have heard this already in other contexts. Let me briefly give you an overview of the high-level architecture and some characteristics of this, and then move on to a detailed explanation of ODP and what this means for you as a consumer in ADF. Here on the right hand, you see a diagram with the high-level architecture. On the left, you see the SAP source system, including the ODP or Operational Data Provisioning Framework. In the middle, you see the self-hosted integration runtime as a proxy, which basically does the RFC communication between Azure Data Factory and the SAP source system. And you see Azure Data Factory on the right-hand side, which orchestrates the whole communication. So, as I said, the whole scenario is based on the usage of a self-hosted integration runtime, which mainly provides the benefit of extending the reach of this solution. So whether the SAP system is hosted on premises or in on any hyperscaler's infrastructure, whether that's Azure or another hyperscaler, doesn't matter. Via the self-hosted integration runtime and installing the self-hosted integration runtime close to the SAP source, we're able to reach out to any SAP system in the world, pretty much. So that's a huge benefit of this architecture. Another important aspect is that this setup has no footprint on the SAP side. So we don't require any installation on SAP side and no associated application lifecycle management, no headaches regarding upgrades on SAP side or any impact. We only use the ODP API as it is, and we're consuming this. There's nothing you have to install on the SAP side. Of course, some configuration is needed there. That's basically configuration which is very similar to what you would do, for example, when communicating or when connecting a BW system to the SAP source system. But as I said, no installation required. The points here on the bottom. As I said, and just like the other connectors, this new connector is available in Azure Data Factory and also in Azure Synapse Analytics. So in both scenarios, you can use it. And finally, and that's a very important point, this connector is available both in the copy activity in ADF and in the mapping data flow. These two options are different in characteristics. So when you use it in a copy activity, you basically get the raw change feed as it comes from the ODP framework. We offer data flow templates, which help you processing the changes in the right order, doing the deletes, updates, and inserts in the right order, and so on. With the integration in the mapping data flow, all of this comes out of the box. So that's basically a much simpler experience. The data is much easier to consume in the mapping data flow, and you can apply your business transformations right away in the same data flow without having to separate the processing into the copy activity and further processing in a separate mapping data flow. So it's a much more integrated and smoother experience than the separation with the copy activity and those templates which I mentioned earlier. Also, very important to mention, where do we stand with this from an availability perspective? The ODP functionality which I'm demonstrating and explaining today is currently in public preview. So it's available in all Azure subscriptions and you can use it. However, it's not yet generally available and we're currently working on a GA timeline and will publish this as soon as possible. So let's have a closer look at SAP ODP, or Operational Data Provisioning. What is it? It's basically a framework which has been implemented by SAP for data exchange between SAP sources and consumers. So the initial focus was on data integration between SAP ECC and SAP BW, but over the years, both on the source side and the target side, the number of providers, which are basically the sources, and consumers on the target side have increased. So as you see here, and we'll go into this in more detail later, there's a long list of data providers which can provide data to consumers via ODP, and also on the consumer side, it's not only used by BW, but many other SAP tools have adopted this framework. For example, Data Warehouse Cloud can consume it, SAP Data Services can consume ODP, and many third-party ETL vendors have adopted that API as well. What are the key benefits of this, and why did we opt for implementing a connector which can talk to this ODP framework as well on the ADF and Synapse side? Well, first of all, you see this rich variety of sources here. So basically, all the SAP ECC extractors, which have been around for many, many years and basically been built by SAP to provide meaningful and consumable data out of ECC systems, for example, to BW, but also other consumers, they can be consumed and they are available with this connector now to us. The same applies to the kind of next generation of extractors in quotes, which are the so-called S/4HANA CDS views, right? So that's basically a new technology with, at least in the area of data integration, a very similar purpose. So they basically expose views which are meant for data extraction and consumption in an analytic context. Then there's SAP BW, right? BW objects can also be consumed via the operational data provisioning framework. So if you have a BW info provider, like a data store object, an ADSO, an InfoCube, all this can be extracted via ODP. And another very interesting aspect is the integration of the SAP LT replication server, or for short SLT, with the ODP framework. SLT is basically a trigger-based table replication engine, which can feed changes, inserts, updates, deletes on table level to consumers. And in this context, it will basically feed this data into ODP from where consumers can read it. So that's basically, as opposed to the other objects where we're basically talking on a higher, more logical level, this is an integration on table level, which is very attractive as well. So this variety of sources which you see here is one of the huge benefits of this new connector, and the fact that we can also consume the ODP framework. Another important aspect of the ODP framework are the built-in Delta or CDC capabilities. So for many of the sources which you see here on the left-hand side, ODP is able to not only expose the data via full loads, but also in an incremental or Delta mode, so that you can basically only get the changes which have accumulated since your last request. And the value of the ODP framework in that aspect is that it takes care of the state of its consumers. So ODP knows you as a consumer, or ADF, your ADF as a consumer, and will basically be able to determine which changes you already have received and which changes need to be sent over to you in your next request. And you don't have to take care of watermarking in that respect or any kind of state management. All this is done out of the box by ODP, which makes the consumption of a change feed much, much easier. And finally, the ODP framework provides a very simple to use, robust and scalable way of consuming the data. Simplicity, for example, comes from the fact that if you look at the variety of sources here with a lot of different characteristics in the details, they are all exposed to you via one unified API and in one unified way. So as a consumer, you won't see much of a difference whether you're in your pipeline design, whether you're reading data from an ECC extractor or whether the data comes from a table replication via SLT. Your pipelines and your mapping data flows will actually not have to care much about that, or you will not have to care much about those details, because the ODP framework basically unifies that in a certain sense. Robustness is another very important aspect of the ODP framework. So I told you earlier that the ODP framework takes care of the state of its consumers. So for example, when a load fails, the ODP framework will take care that this data, this change feed, which should have been transferred to the consumer, is not lost or doesn't have to be read again, but make sure that you as a consumer get this in your next load. So basically, you don't have to take care of such error situations. You can assume that ODP will make sure to correct this for you. And finally, ODP provides scalability out of the box. So whether your load is fairly small with a few 100,000 of records or fairly large with, say, 100 million records, ODP will basically make sure that all of these scenarios work out of the box. So let's dive one level deeper into the key benefits which I mentioned on the previous slide. Looking at the rich variety of sources, I mentioned that there are lots of different provider types available via ODP. But even within each of those provider types, there's a huge number of objects which SAP provides out of the box for you. So for example, when you look at ECC extractors, ECC systems come with a huge number of extractors out of the box, which have been built by SAP for the purpose of data extraction. So looking into a standard ECC system, you will find something like 7,500 plus data sources or extractors available within that system meant for data extraction. Similarly, when it comes to SAP S/4HANA, the technology has changed. SAP is moving away from extractors, which are basically like program code, ABAP programs that deliver the data and the changes to consumers, to a technology which is basically more database oriented, the so-called ABAP CDS views. But the paradigm is still the same. So SAP delivers out of the box content for data extraction. In this case, the last number I've found publicly available for S/4HANA is 2,500 ABAP CDS views delivered with the latest S/4HANA releases. And this number is certainly growing. The same applies to BW and BW for HANA. So all the business content, all the pre-built data models which SAP provides, but of course also all the custom models which customers build in their BW systems, they can be consumed via ODP. Speaking of custom built stuff, that's important to mention as well. Of course, customers can also build their own extractors, CDS views, or as I just mentioned, BW objects. And it's also possible to expose and consume those objects via ODP. So whether you use the standard objects, whether you customize the standard objects delivered by SAP, or whether you build your own logic, all this can be made available by ODP and consumed with this new connector. And that provides a huge, huge value. Now let's have a look at the Delta or CDC capabilities that come with ODP and the ODP connector for ADF and SNOOPs. This topic has two sides. On the one hand side, you have the concrete provider or provider type, which I'll get into in a few minutes. And there's the framework aspect of it. Let's maybe start with the framework aspect, because that's the way which is, or the aspect which is exposed to you as a consumer. The nice thing here is that the way change data capture is handled by ODP is very uniform and very simple. Basically, all you have to do is subscribe to a certain provider. So one of these provider types in a very specific object, so like one specific extractor, one specific CDS view, one specific table in the SLT case. And you do that basically by subscribing with and identifying yourself with a unique name. That's something which is part of the modeling experience in ADF when you model your copy activity or your data flow. And with this unique name,
ODP recognizes you as a subscriber and takes care of your state. So basically, when you ask for the first time for data, and you don't have to provide any more information than like, I want to have data in a delta fashion, then ODP will know, okay, you're a new subscriber, so the first data transfer which will happen for you will be a full snapshot of the current data set. When you call again and identify yourself with the same name, and that's within the ADF tooling, of course, done automatically if the same copy activity or the same data flow calls again, then the ODP framework will know, okay, this subscriber has already obtained the full snapshot or a certain sequence of deltas, and it will know what it has to provide to you based on that given state. So you don't have to take care of that state, and you don't have to keep track of it. ODP does it for you, which is very, very comfortable and makes the consumption of this change feed very, very simple. So that's the framework aspect. On the provider side, things are a little bit more tricky. First of all, not, for example, when you look at the extractor case, not all extractors actually do provide change data mechanism or delta mechanism. Most of the extractors, or actually all the extractors for mass data scenarios, do. So it's not something you really have to worry about if you're dealing with something like your purchase orders, your sales orders, your financial data, all those data sets which provide large data volume and where full snapshots on a regular basis would not work. All those typically provide delta mechanisms. Some smaller scenarios, like some certain master data, maybe cost centers or so, in certain cases, they don't provide a delta mechanism, but then again, doing a daily full snapshot is probably even faster than thinking about a way how to determine delta. So in principle, you can be sure that SAP has, with all the content it has built in, with all the scenarios it has shipped, has taken care of delta wherever it's needed. And even though the delta mechanisms are potentially different, in some cases the delta determination is done based on timestamps or date fields. Sometimes it's incremental counters. Sometimes it's a push mechanism, like in the SLT case with those triggers which I mentioned. This, again, to you doesn't matter. It's completely transparent because that's something ODP takes care of. ODP knows what kind of change mechanism a specific provider understands and delivers, and it will take care of that automatically and handle that for you. So as I said, in general, you can be sure that delta mechanisms will be available for all the relevant scenarios when it comes to extractors, same for CDS views. In the case of BW and BW for HANA, it's true for pretty much all info providers, with maybe a few exceptions, but again, that's an aspect of configuration in a certain sense. And in the SLT case, in the case of the landscape transformation replication server, I already mentioned a couple of times that this is basically a trigger-based CDC mechanism. So this provides full delta capabilities, including inserts, updates, and deletes out of the box for all tables. And the last key benefit we had on the initial slide was ease of use, robustness, and scalability. I already mentioned some of these aspects, but let's go over them again. First of all, there's no watermarking required on the consumer side. Consumption of a change feed, of a delta stream, is very, very simple. You basically say, I want to subscribe to a delta feed, and because the ODP framework keeps track of your state, because it knows its consumers, and that's part of the protocol. When ADF calls into ODP, it provides identifiers, unique identifiers, so that different subscribers of the same source object can be distinguished. Basically, when you call multiple times, the ODP framework knows your current state and knows what delta you have to get, whether you have to get an initial snapshot on the first request, or if you have to get subsequent delta and what exact portion of delta you need to get, and it will provide you with the right data. There's nothing you have to worry about. And that's basically how ODP handles this, and that basically also means that the modeling on the consumption side is very, very simple. As I said, nothing you have to worry about. You design your pipeline, you run it multiple times in delta mode, and you will get the right change feed. Similarly, ODP comes with built-in recovery mechanisms. So when a load fails and is not completed successfully, ODP will make sure that the data of this load is not lost, but it will keep it for you. And when you run your next load, it will provide that data again, so that you can make sure that you will not have any missing data in between, which is of course a big pain in a delta stream. ODP will always make sure that your delta stream is consistent. That's also a huge benefit and makes dealing with this change feed much simpler than many other scenarios. And the last point, when it comes to scalability, well, there are many aspects to this. First of all, ODP provides the data in packages of a configurable size. So you can basically say, even if you have a huge data load, which you want to run, you can specify that you want to chunk it into packages of some size. The default size is 50 megabytes, but you can specify any other value, and ODP will make sure that it basically provides data in those in chunks of the prescribed size, and you can fetch it in those chunks. So basically, with this mechanism, it's very easy to scale in a pretty much linear way for large data volumes. Then there's another aspect which is the point 2 here, parallel read on ADF side. I already described, and you probably understood by now, that this mechanism is not a synchronous communication between the consumer and the provider, but ODP acts as a broker in between and intermediately stores these packages I was just talking about. So basically what happens when a load is started is that ODP calls the provider, requests the data in packages, stores these packages intermediately, and then the consumer can start fetching. And this is pretty much a handshake mechanism. So when the first package comes in, the consumer can start fetching. That's what ADF does. Plus, you can configure how many parallel readers you want to have on the ADF side. So if you realize that the SAP side, the ODP side, or the provider on the left-hand side here can provide the data in a very fast way, then you can actually tune the number of readers on the consuming side to make sure that you read at a sufficiently high speed and basically retrieve the packages as they come in. So that's one way of tuning. Another way of tuning this and dealing with large data volumes is that you can also partition loads. So that's especially an aspect which is relevant for large initial loads. You can basically via selections partition a large load into multiple smaller chunks. You can, for example, partition by, well, in principle it works with any field the provider allows. It could be, for example, a time field, so you can, for example, chunk or create partitions based on dates, on calendar years, for example. You can also use regions, whatever is suitable in a given scenario. And then all this process, which I was describing, the process of reading the data and storing it in the ODP framework and reading it on the target side, this can actually be parallelized. So you can have multiple jobs running on the SAP side, producing the data for each partition at the same time in parallel. And you can have the reading on ADF side parallel as well. So by this, you can also speed up large initial loads by partitioning them. And a last point which I would like to mention here is that adjusting the resources of the self-hosted integration runtime, in particular the CPU resources, also allows you to size and configure and scale the throughput of the data transfer between the SAP source system and Azure Data Factory or Azure Synapse Analytics. Before we move on to the demo part of this session, I want to spend a few words on the different provider types which are exposed by ODP. Remember on the previous slides, we always had this list of provider types like ECC extractors, CDS views, tables via SLT, BW objects. And we get a lot of questions by customers asking us, what's the right choice for my given scenario? And this answer is not always simple, and there's no right and wrong. It really depends on specific use cases, but I want to give you some understanding and maybe some guidance and some criteria which might help you come to the right choice here. In this diagram here, you basically see there's a stack of objects. You see the tables, which your SAP system is based on. On the bottom here, you see objects like extractors and CDS views on a higher level, and that's an important point to understand here. So basically, this gives you two options from a semantic perspective. You can either decide to go for data on table level when you consume via ODP, which, as we already saw in a couple of slides earlier, requires an SLT server to be installed either on the same application server as your ECC system is running on, or there's also a hub installation of SLT, so you can also install it on a separate server and connect it to your ECC system to avoid dependencies when it comes to application lifecycle management, for example, or even to connect multiple ECC systems to the same SLT server. So that's one option, and the key benefit of this option, the main advantage, is that in this case, data is the change data capture and the delta mechanism is very simple. Data is easy to replicate, right? Because everything happens on table level. Creating triggers on tables, evaluating the changes is very, very simple and straightforward. On the other hand, what this means from a consumption perspective, I mean, it's not only about replicating the data into your target system. In the end, you also want to consume the data or make it consumable to business users, right? So in this case, you basically need to understand the dependencies between the tables. You need to know foreign keys between them. You need to know which tables you need for a certain scenario, how they relate to each other. So you need a much better understanding of the application logic and the application design of SAP in this case. It's doable. There are a lot of customers have been doing this. A lot of customers who have in the past been using our SAP table connector are also working this way. So it's not like this is impossible, but it's additional modeling work which you have to do. The benefit, as I said, is that replication is very, very easy and straightforward. With extractors and CDS views, the situation is pretty much complementary. So even though I think I already mentioned that these two object types are different in technology, the paradigm is pretty much the same. They both expose data in multidimensional formats. So a CDS view or an extractor can either be of type fact or dimension, or it could be text or hierarchies. That's basically the types that exist. And therefore, the data model exposed by extractors or CDS views is much easier to consume than the application data model which is coded in the SAP tables. So consumption is easy when you're using extractors or CDS views. Modeling the data on target side becomes quite straightforward and easy. But because there's logic happening and like joins, aggregations, additional conversions between the tables from which an extractor or CDS view gets the data and the output structure of those objects, determining changes is more tricky. So to summarize the situation, basically if you go or decide to work on table level, then replication will be pretty straightforward. You will get delta potentially in near real time via SLT with this trigger mechanism. But on the modeling side, you will have additional efforts to assemble the pieces, right? Basically construct a consumable data model out of the third normal form given by the application tables. With the higher level objects like extractors and CDS views, it's pretty much the converse. Consuming the data will be much simpler and you will have less modeling efforts, but you might not have the same level and the same service level when it comes to delta. And with that, let's move on to the demo section. The first demo I have prepared is based on an S/4HANA system, and I have picked a CDS view here, which will consume via the ODP connector in a mapping data flow. So here's my data factory, and I've already opened the pipeline, which we are going to look into. And you see the pipeline is very, very simple. It only has one activity, which is a data flow. Now, this data flow is also very simple. It just consists of a source and writes the data from the source directly into a sink without any additional logic. So just a one-to-one copy from source to sink, including updates when we later run this in a Delta mode. Let's have a look at the source first. What you see here is basically the source settings, and you see that we're using a data set called ZIFIGL-ACCT-LIR, which is based on, and I can open it here for you. You see it's based on an ABAP CDS view with that name, which, and I'm now switching to the SAP source system, is basically a CDS view on, well, not exactly the AC.A table, which as for people with some exposure to S4HANA will be familiar with. It's basically, AC.A is the central accounting document table in S4HANA, so one of the most central objects you will find in that system. I created a copy, that's why everything here has a Z in the beginning. So I created a copy of the table and a copy of the views on top of the table, and basically all the also the CDS view is a copy, but it's really pretty much copy and paste with the slight modifications of adding or exchanging the real objects with the copies. But everything else is pretty much the same. For those who are familiar with CDS views, this section here, those annotations, basically define the data extraction capabilities of that CDS view. There's a lot of documentation around it. This CDS view actually supports change data capture. So it also supports a CDC mechanism based on triggers in that case. So that's a new feature in S4HANA, which kind of combines technology similar to what we've talked about in the SLT context with CDS views. So you will get a very nice and beautiful change feed from that view. Down here, you see the view definition. That's a very complex thing. You see that it's very, very long. If I scroll down, you will at some point start seeing the list of attributes of that view. Yeah, that's here with a lot of semantics. So each attribute which you find has additional annotations which describe the meaning, and there's a lot of metadata around it. There's also a renaming happening from the kind of cryptic acronyms which many attributes in SAP tables have, to something which is more readable. So all of this is happening in this view, but that's really not what we are interested in. We are basically interested in using this view for extraction, right? So let's go back to the to my ADF, and as I said, basically in this data set. This data set is defined on top of this CDS view. So for example, when you do a preview here, you would see the data coming from that CDS view. So now let's move back to the data flow here. We have covered the data set. Basically, here you see that in the source options, you can first of all down here define the key columns of that view. Typically, the system determines that, or the connector determines that automatically. If the source object comes with a field with a key definition, this is automatically retrieved, and you can see that here. This view has 5 key fields, and you can also define the extraction mode. So you can either go for a delta subscription, which is described by this here. So it's a full on the first run of the data flow, and then doing incremental loads, right? So that's basically subscribing and getting a full load first, and then subsequent calls will give you the change data only, as I described earlier in our context in our theory chapter on ODP. And the other options, of course, you can also decide to run it only in full mode. So basically do full loads, but that's not what we're interested in. We're really interested in looking at the incremental loads here. So that's basically the main configuration on the source side. And then, as I said, there's no logic happening in between. We just write this data to a sink, which in this case is an a table in Azure Synapse Analytics. So I basically defined in a dedicated SQL pool, I created a schema and a table into which we are basically going to write that data and updating it. So here you see the target data set, and when we look at the settings, you'll see that we will basically doing inserts, deletes, updates based on the same key definition as we had in the CDS view, right? When we do these operations, inserts and updates and deletes, in order to determine what operation to do on the database, you also need the key definition in the same key. Before we run this data flow, let's have a quick look at the SAP side of things. This tool here is the monitoring tool for the ODP framework. And what you can see is that basically right now for this operational data provider, that's basically the CDS view, which we were just looking at, right? Remember the name. The provider type is ABAP Core Data Services. So that's the source object which you're looking into. And you see that right now there's no subscription existing for this. So nobody has subscribed to get data from that source object at the moment. And once we start our mapping data flow in our pipeline, we'll see that this changes, that data gets produced on SAP side, gets read from the ADF side and processed in the data flow. So let's go for that and let's trigger the data flow now. And while the pipeline is running, let's move back to the SAP side, and you see that in the monitoring tool here, we now find a subscriber. So we find a line here in this table, which basically indicates that our call has reached the SAP system. So you see one request, which means one load. Let's refresh this, and we should see that a couple of data packages have been loaded. 162,000 records have been retrieved from this CDS view, written into this intermediate storage on the ODP side in the so-called delta queues. That's where this name queue comes from and what it refers to. And while I'm talking now, the self-hosted integration runtime is retrieving the data, fetching the data from the SAP system, moving it over into Azure, and the data flow is going to start processing the data and eventually updating the table in Azure Synapse Analytics, which we looked into earlier. So now let's check what's going on the ADF side. Here we see in the monitoring tool on ADF side that the data flow has completed successfully. Reading the data from the sink was successful. Let's check some details here. We see that the right number of records has been retrieved. We also see that the right number of records has been written into the target, so that all looks good. And with that, we can now move on to my Azure Synapse workspace and see and verify what data we see in the target table. So here we are in the Azure Synapse workspace. This is the table, and I have prepared a simple SQL statement which should give us some indication of the data which has been written into that table. And now let's see if that matches what we expect to see. If I bring this up a little bit, I guess summing up these numbers, so I have basically done a count star group by source ledger. Summing up these numbers looks pretty close to what we expect, the 162 something records. Let's quickly cross-check this on SAP side. I have opened the SQL editor inside SAP GUI, and I'm basically running the same query with slightly different syntax because it's running directly on the source table, not on the CDS view. That's why we see the cryptic names and not the more human readable names as we saw on the Azure side. But let's run this query and check that we see the same numbers, just for the sake of completeness. Yes, and that's pretty much the same. Now, the next thing I would like to do is do an update directly on this table, on the AC.A table, and then do another run of our pipeline and see that those changes are then basically transferred over to my Synapse workspace and are actually updating my target table as expected. So what I'll do is basically an update on those records with source ledger 1C and update the value 1C to 0C. So let's move over here and exchange that SQL statement with this here. So I'm going to do an update directly on the table, setting the source ledger to 0C where the current value is 1C. This should basically change those 20 records which we just saw. Now let's run this. The statement has successfully executed. And now we can go back to the ADF side, run the pipeline again, and see and verify that our data flow fetches those change records and updates my target table as expected. So let's move back to the ADF side of things, trigger the pipeline again, and verify that it executes as expected. There we go. Now, in a few seconds, we should move back to the SAP system again to verify that a couple of records are now being determined. The changes are being determined, written into the queues in the ODP system on the ODP framework side, and then retrieved by ADF and processed by the data flow, and eventually updated on the target table. Back to the monitoring tool in ODP, we see that there are now two requests, so basically two loads, which looks good, right? Because we have the initial load and the subsequent delta load. We see that the second load has produced 40 records, which is a bit surprising because we only modified 20. But that's actually due to the fact that for each record which has changed, the ODP system transfers the old value and the new value. So it basically gives you for each update 2 records. You can actually even verify this in the ODP monitor and really dive down into the data which is contained in that load. So you would eventually down here even see all those records. Now this is a bit slow on my side today. But if you go down here and check for those records, unfortunately this is a bit lagging today. But you would actually be able to identify that for each key you find 2 entries, one with the old value and one with the new value. That's why we come up with these 40 change records instead of the 20 which we actually have in the system. That's, by the way, something we should also verify here. So if we run the previous SQL statement again, let's do that to see that the update has actually done what we expected. And you see that we have 20 records with source ledger 0C. So moving back to our data flow, we see that the second run of the data flow was also successful now, and it has retrieved the changed data. So basically, we should now be able to verify that the target table has been successfully updated. This is still the result of the previous run where we see 20 records with source ledger 1C. And if I re-execute this query, we should now basically see no changes on the other numbers and 20 records with source ledger 0C. And here you go. We see we have these 20 records with source ledger 0C. The order has changed. Let's be extra cautious and check that we still see the right number of total records in total. So let's do this select count star without any group by on the table, and we see that this is the original number of records. So even though 40 records 40 change records have been stored on the ODP side and transferred, the mapping data flow determined the changes correctly and basically ignored the old versions and only updated the new version. So that's part of the benefit which you get from the mapping data flow, that it knows how to interpret this change feed correctly and how to perform the right updates and deletes on the target structure. And you get all that for free with the intrinsic logic in the mapping data flow in Azure Data Factory. The setup for the second demo I want to show you is slightly different. We're now not accessing data on a logical level, not via CDS view or via an extractor, but directly on the table level via SLT. And we are also not using the mapping data flow directly, but a combination of a copy activity and a pipeline we created based on templates which we provide in the ADF template gallery. What you see is an ADF pipeline created from templates which we deliver to our customers to reduce their development efforts. The pipeline first does a copy activity in SAP, followed by a mapping data flow that processes the changes and updates the SQL table in Synapse. As you can see, some sorting, deduping, and other steps are required for that. The pipeline loads data from SAP's purchasing table EKKO. In our monitoring tool, you can see that I've already run the pipeline for a first time to do an initial load. Let's verify on the Synapse side that we see some data in our Synapse table. In a few seconds, you will see that 16,221 records have been copied over. On the SAP side, we can verify that this first pipeline run has initiated a Delta process. From this feed, we will now be able to read changes we do in SAP purchasing. So let's move on to the SAP purchasing application to create a new purchasing order. For the sake of simplicity, I will use an existing purchasing order, which you can see on the left as a template. I'm adjusting the purchase order quantity and save the purchasing order. Let me also copy the purchase order number so that we can later on retrieve it in Synapse. Now back on the ADF side, let's trigger the pipeline again. And after a few seconds, we will see that the copy activity has read exactly one row from the SAP system. And a few seconds later, the mapping data flow has succeeded as well. So now we can move on to the Synapse side to verify that we have retrieved the correct data. Let's first do a select count star again to see that one more row is contained in the table now. And you see that's exactly what we expected. And to prove that this is really the newly created purchase order, let's modify the select statement to a select star from the table here with a where clause filtering out the purchase order number we just copied on the SAP side. And as expected, we will find our purchase order just created in SAP. So let's close off with the key takeaways of this session. Number one, the new source capabilities available with the ODP connector. When it comes to sources, keep in mind all the different source types available and the wealth of objects within each source type, which you can access with this ODP connector. When it comes to capabilities, keep in mind the CDC capabilities you get. So basically a change feed which you can consume. Also keep in mind the scalability and robustness features of this new connector and of the framework it resides upon. Secondly, keep in mind that this functionality is available both in Azure Data Factory and in Azure Synapse Analytics. So in both of these worlds, in both of these scenarios, you can make use of that new connectivity. And last but not least, keep in mind the direct integration of the ODP connector into the mapping data flow, which provides significant value in at least two senses. First of all, it makes modeling much easier. You don't have the separation between a copy activity and a mapping data flow. You model everything in one environment. And secondly, within the mapping data flow, the source operator basically interprets the change feed in the correct way for you. So remember this, in the first demo, we had these 40 change records because the raw change data as it comes from the SAP system contains the old values and the new values for each updated record. With the mapping data flow, these changes in this change feed is interpreted correctly and the updates are done in the right way. You don't have to filter out anything or worry about the details of this change feed. It's all done out of the box for you. And with that, I would like to thank you for attending this session. I hope you enjoyed the materials and got some inspiration for your future data integration projects based on SAP and Azure.